welcome everyone to Microsoft Build and this Learn Live session. I'm super excited to talk about today and going through the Learn module for the introduction to Azure Arc-enabled Kubernetes and how you can manage your on-premises or multi-cloud Kubernetes through Azure. So with me today, I have Mike, and I'll let you introduce in just a bit. My name is Thomas Maurer. I'm a program manager for Azure Edge and Hybrid. So again, very excited if you're today in the call. You have the link and the QR code here, which is a Microsoft Learn module, which you can follow through and actually learn about the technology. And we will go through that Learn module together here, but also after that session, you will be able to go through that on your own pace and learn about these technologies. So again, this is going to be the Learn module. We will show you that live, and again, we'll manage through that. It's a very good experience to actually learn about the technology. Also, this is very interactive and should be live, right? So feel free to type your questions into the chat and ask. We will try to answer as many as possible. We also have some great moderators and producers here in the background doing all the great work to try to answer questions, making sure that everything runs smoothly. So make sure to type those questions and get your questions answered. And if you're lucky, we will probably, and if you have time, we will probably try to answer them on the screen as well. So with that, a quick look at the learning objectives and what we have in this Learn module. So we will obviously go and learn about what Kubernetes, or get a quick introduction into Kubernetes and Azure Arc, but especially obviously on Azure Arc-enabled Kubernetes. So Mike will go through and tell us all about what it is and why it is so important. And then we will go through and see how you actually can use Azure Arc to connect your Kubernetes cluster to the Azure control plane. We will have a look at managing of policies. We'll have a look at GitOps configurations and many other things in this Learn module. So absolutely, let's just dive into the introduction part, and let's go to the Learn module itself. Again, if you use one of these links or QR codes we showed before, and I'm sure our moderators can also put this into the chat as well, then you will find that Learn module. It will again summarize a little bit on what I just said and what we're going to learn. And you can see here we have different parts or modules in this learning path where you can look at. And with that, let's go into the introduction. And again, this is very quick. You can read through this on your own time, but obviously in this world, we are not just having cloud services running in our Azure data centers, which, by the way, is actually a great choice to do. But there are reasons why you would want to run your applications and your workloads on premises, at the edge, or even at other cloud providers. And we want to obviously look at how you can build this single pane of glass, this control plane, and use basically the same management tools as you use for your Azure deployments. Use the same ones also on premises or at the edge, and we will go through this specifically. So there's a couple of things you need to know about and some prerequisites to go through. I don't want to spend too much time on this, and let's just dive into the important part here with Mike, who will introduce himself as well, and we'll cover what is Arc-enabled Kubernetes.
Yeah, hi folks. Welcome to Build and to this session about learning what is Kubernetes and how Azure Arc is going to make managing Kubernetes across multiple platforms much easier. My name is Mike Kostersitz. I'm a PM lead in the AKS Hybrid team, and I own all the core Kubernetes components in AKS Hybrid with my team, and we drive all the Kubernetes implementations that Microsoft has at the edge. But more to that a little bit later. Before we focus on kind of like Azure Arc and optimizing management for Kubernetes clusters and the workloads, it's really important to kind of talk about what is Kubernetes, what is Arc, and kind of so we have kind of the same language going along. So Kubernetes is an extensible, mostly Linux-based open source platform, and it allows you to orchestrate containerized workloads. To ensure resiliency, each Kubernetes deployment consists of multiple clustered servers. They could be virtualized, they could be physical. Some of them function as control plane nodes. Some of them are which are responsible for managing the remaining workloads and the workloads that are containerized. And using Kubernetes, these workloads run as pods. So that's kind of the smallest denominator in Kubernetes. A pod can contain one or more containers. Usually it's a one-to-one relationship because you want a separate IP address, a separate port number for your application that runs inside a pod. But sometimes there is tightly coupled ones that you want to run side by side, and that kind of like work in the same pod. But that's kind of the exception to the rule. Let's put it that way. Besides container-based isolation, Kubernetes offers also abilities to isolate through namespaces, which is kind of a logical grouping of objects in Kubernetes. Mostly you'll group things like pods, services that expose the application to the outside, and kind of that's the logical network settings, credentials. So that's kind of the logical grouping of things. And that helps you to provide isolation between users and workloads across multiple worker nodes. So what does Kubernetes really do? It helps you abstract away complexity of managing multi-container environments. So imagine you can use something like Docker to run a single container or like a handful of containers. And it's kind of easy to manage and that you don't have to deal with Kubernetes and the complexities it brings. But once you're running like applications across multiple platforms, say you have a portion of your app that runs on-prem, but you're using cloud services like AKS to add machine learning, training your models and things like that, and you run those in the cloud. Now you have, and you run that in multiple clouds, now you have spread across thousands of containers potentially to manage, and doing that with by hand, quote unquote, with a single Docker instance is kind of difficult. And so Kubernetes helps that by abstracting that away in a declarative management model where you have like a text file, which is YAML formatted. And it took me a while to kind of figure out how YAML works, and it's kind of a little bit tricky to figure out, but once you got it down, it's actually fairly straightforward. And if you have a lot of YAML files, you kind of could become overwhelmed. So there's a package manager that allows you to package multiple YAML files for an application and the infrastructure that works, that make up that application into a Helm chart. And that chart is kind of like a map for Kubernetes to actually publish that to a defined environment. And because you can parameterize these Helm charts, you can actually use the same Helm chart to deploy on-prem or in the cloud by simply changing a few parameters without having to change around your application. In addition to that declarative model, though, the control plane in Kubernetes brings things like auto-scaling of pods in virtualized scenarios, also cluster nodes. So if you're running AKS hybrid maybe on Windows Server or Azure Stack HCI, now you can actually auto-scale your nodes as your demands grow. Same with AKS in the cloud or with other Kubernetes services that are run by hyperscalers. Now you can actually scale your environment as your demand grows. And when the demand goes back, like past Memorial Day sale, everything shrinks down to your steady state, and you only pay for what you use, basically. It does automatic rolling updates and rollbacks for pod deployments, and obviously also for virtualized nodes if you have that. You have automatic discovery of new pod deployments, so you deploy an application, DNS resolution, and service discovery is all built into Kubernetes. You don't have to worry about those things. It is important, though, that Kubernetes is a highly customizable orchestration platform that requires proper configuration management and maintenance. So it's not kind of like a one-click install and then you just turn around and forget about it. Manage Kubernetes, and that basically requires some knowledge there. And this is kind of what we're going to talk about as we talk about how Arc helps you manage your Kubernetes environments and kind of like simplify those things. Managed Kubernetes offerings, just like AKS in the cloud or AKS hybrid, minimize or to a certain extent also eliminate some of those challenges, but not all of them. So there's always something new to learn here and new features that will be introduced. So now that we have kind of like a common understanding of what Kubernetes is, let's switch over to what is Azure Arc. And this is kind of like a busy picture, but it gives you kind of an overview of a evolving business technology landscape that is becoming increasingly more complex. As you can see, you got multi-cloud Arc-enabled services at the bottom right, multi-cloud IT infrastructure resources like VMs and SQL databases or Postgres databases, whatever, what have you. You got on-premise Arc-enabled services, and we'll talk about those in a little bit, and IT infrastructure resources on-prem. And to provide you with a single pane of glass kind of view, Azure Arc is the bridge that helps you connect all those on-prem and multi-cloud resources to your Azure cloud and reflect those into Azure so that they look like Azure resources. And so when you deploy services in Azure, like a SQL database, a virtual machine, a Kubernetes cluster, you kind of use to manage those through the portal, Azure CLI, or the ARM REST APIs. But now you can actually also see your on-prem resources or other cloud resources in the same pane of glass and apply the same models for security, monitoring, governance to those resources. So let's talk a little bit about what types of resources work with Azure Arc. And we got Azure Arc-enabled services at the servers at the lowest level, which is basically physical and virtual machines running Windows or a supported Linux operating system. So Arc would deploy an agent to each one of those, and that agent will help reflect that resource into the cloud. And now you can manage your servers just like you would on-prem, but through the cloud portal, Azure CLI, and APIs. There's SQL Server. So once you have your Azure Arc-enabled servers, now you can actually deploy other things to that or manage other things using the same agent, like SQL Server instances on those Azure Arc-enabled servers. Azure Arc-enabled Kubernetes, say you run Rancher or OpenShift, but you want to manage that through the cloud, through Azure. Now you can actually use Azure Arc-enabled Kubernetes to reflect your on-prem Kubernetes clusters into the cloud. Azure Stack HCI has built-in management of virtualized workloads and containerized workloads through Azure using an Azure Arc-enabled servers agent, a slightly different version, but similar concept. And on top of Azure Stack HCI or Windows Server, you can also deploy AKS, which is AKS Hybrid, the product I own. That allows you to manage your on-prem Azure AKS clusters the same way you manage your AKS clusters in the cloud. Apply the same policies, everything. And we get to more of that as we move through this module. And then we have, last but not least, we have Azure Arc-enabled data services, which is an Azure SQL managed instance running on an AKS server on Azure Stack HCI. Make sure, though, we have a lot of other Arc-enabled services that are kind of in preview right now. So if you want to play around with those in a non-production environment, go ahead. But for production environments, make sure that you're using the GA version of each of those services because that's the only way you get really support for those. So let's skip ahead and say, what are the benefits of the key benefits of using Azure Arc? As I mentioned, it's the ability to organize all your resources by using Azure management groups, resource groups, subscriptions, and tags, the way you would your cloud resources. You manage or organize your cloud resources. It's a single, very comprehensive inventory of all the assets across multiple clouds, on-premises, and you can search and index those using the portal APIs or Azure Resource Graph. It also gives you a consolidated single pane of glass view of Azure Arc-enabled resources through the portal APIs or the Azure CLI and Azure PowerShell, actually. While some of the services like AKS Hybrid also give you an on-premise way to manage your AKS clusters should you get disconnected for a period of time. So there's different things there that you can do. Delegation of permissions and management for the management plane, but also on the resources is handled through Azure RBAC, which is our role-based access control model based on Azure Active Directory. That stretches all the way down to the namespaces in Kubernetes, for example, that we talked about earlier when we talked about what Kubernetes components are there. It does support log analytics and also slicing log analytics based on RBAC rules, and integrates with Azure Monitor. All those Arc-enabled services integrate with Azure Monitor, and Azure Monitor helps you monitor all the resources you have deployed. And that gives you cloud-based monitoring across Azure resources, on-premise, and other cloud providers. So with that, I'll test now that you all have paid attention to this flood of information, and we'll jump into the first knowledge check.
Yep, let's have a quick look on the knowledge check here. By the way, great stuff here. By the way, there's also one question in the chat, which I quickly want to go into and fair an answer, because we talked about these Arc-enabled benefits. And so Michael had a question: if deployed AKS on-prem using Arc and Azure Stack, guess he means Azure Stack HCI in this case, will on-premise AKS, our AKS hybrid options, have access to the Azure Key Vault for managing secrets? And the answer to that is yes, there is a extension available for Azure Arc-enabled Kubernetes, not just for AKS Hybrid, but for all the Kubernetes distros you manage through Azure Arc. You can basically go in and push down that extension to get these, to fetch these secrets. So great stuff. Again, keep the questions coming. We will try to answer as many as possible. There's a ton of other questions here already, but we'll try to pick some of those. So let's go through the knowledge check here with the first question here. What is the format of the Kubernetes manifest file supported by Azure Arc? And again, you can vote using that link or QR code here and try to see if you get it correct. We will also see the live results here on what you're voting on, and we'll give you some extra time here to actually do the votes, and we will see if we can go through this. So Mike, again, we have like 4 options here: A, XML, B, YAML, C, JSON, or D, TXT. So well, I had to laugh a little bit on the last one, to be honest. I mean,
text. In theory, TXT is a right answer, right? Because a YAML file, or a configuration file or manifest file is a text file, right? It's clear text. But yeah, so I do see that there's we have a wide consensus on what the right answer is, I think. But we'll wait for a few more seconds until the last votes trickle in. But yeah, so XML, I don't know who in the audience was around when XML was the thing. I've been around XML for a long time. I've seen it showing up. I've seen it go away, and I've seen it come back again. JSON is kind of an interesting thing. So that's kind of a mix between the right answer and the wrong answer. And so TXT, well, as I said, it's kind of a right answer, but it's not really the right answer. So we'll settle on. I think we have settled pretty much. So the majority has come up with YAML as the right answer. I think that's a great answer. It's the right answer. So now, who likes the extension YAML, YAML, and who likes the extension YML? That is the question. So when I do presentations and demos, I try to have a mix to please all the crowds. It's like GIF and GIF. You know, it's kind of like all a philosophical discussion. So for those who said JSON, that is definitely also a sort of right answer. You can use JSON for certain things in Kubernetes and for managing containers, but the predominant format is YAML. For those of you who said XML, I'm sorry, but that doesn't work. But it does work again against the Azure REST APIs. It doesn't work against the Kubernetes APIs. All right, let's go on to question number 2, Thomas.
Yep, absolutely. So this one is an interesting one, and I know that you just talked about this, and you, well, are probably a little bit biased if that's a great idea. So which technology makes it possible to deploy the Azure Kubernetes Service, or short AKS, in an on-premise data center or even an edge location? So imagine the scenario where you probably don't have necessarily a lot of knowledge on Kubernetes like itself, or you have a lot of knowledge on it, but you want to have something which makes it easier for you to deploy and manage it. We have here different options here. So again, feel free to vote again for the right answer here. We see already some questions, some coming in. So we have A, GKS, B, EKS, C, Azure Stack HCI, or D, OpenShift. So again, this is all about where can I run the Azure Kubernetes Service, AKS, hybrid, on premises or at the edge. So there are different technologies which make that possible, or there's one technology which makes that possible, if you will. And maybe, Mike, you will also expand a little bit on the answer, because it's not, maybe not just one answer there, or the answer needs to be probably a little bit extended there.
Yeah, the correct answer here is definitely the one that does not involve being a Kubernetes distro in this case, right? So AKS is kind of on par with other Kubernetes distributions that are available for the edge, and as a platform, the platform that we have here is built on something that has been around for quite a while, and I've been at Microsoft for almost 30 years now, and I've seen it come up from OS2 LAN Manager all the way through Windows NT3, Windows Server 2000, and go all the way to what Windows Server 2020 XX is going to be when the next release comes out. And so the right answer here is Azure Stack HCI. GKS is the Google Kubernetes service. EKS is the Elastic Kubernetes service of Amazon, and OpenShift is a platform provided by Red Hat / IBM, which is also a Kubernetes distro, which basically maps to what AKS, the Azure Kubernetes service, is. So Azure Stack HCI is built on top of the technologies in Windows Server. And with AKS hybrid deployment options, you have multiple ways to deploy on Azure Stack HCI or Windows Server, actually. So if you have a rack full of Windows Server sitting somewhere, but you don't want to go down the Azure Stack HCI path, but want to reuse the servers you already have, you can deploy AKS on those in a highly available, clustered manner. If you have a single box somewhere in a broom closet, you can use that as well. So single node deployment works as well. You can also use AKS Hybrid Edge Essentials, which is a smaller converged version of AKS Hybrid, which is kind of like the full scalable version of it, that you can deploy on Windows IoT. You can deploy that on Windows Enterprise embedded. You can deploy that on Windows Server embedded, so you can use that for driving industrial solutions, for example. So yeah, Azure Stack HCI is the predominant answer here, but as I said, there's multiple options. We also have projects going on in private preview that work on non-HCI or Windows Server platforms. So that is something interesting that's coming up. So keep your eyes and ears peeled for Ignite this year. So that's kind of a plug for the next conference, where there might be some exciting announcement around that. So let's move on to the next topic.
Yeah, definitely looking forward to that, to these announcements. Yeah, there's again super exciting possibilities to run. You mentioned again running into also like AKS Edge Essentials on these IoT, but also it works on Windows 10 client. Like if you have, I think, a Pro or Enterprise license, or Windows 11 even, I should say. Probably most of you are already on Windows 11, at least I hope so. Then you can also use that. And I love it, as you also mentioned, it can also run like AKS hybrid deployments like let's say on Windows Server, for example, can run on a single box. So if you're getting started with Kubernetes, I think that's a perfect way of trying it out. Like install yourself a Windows Server or even use a Windows client operating system and then deploy the AKS solution, and you will like have all these features in the time to learn. So let's switch to the next unit here. And that talks about the architecture components of Azure Arc-enabled Kubernetes. So Mike, can you tell us a little bit more about these components here and the architecture?
Sure, let's jump into that right away. So I was hoping to have a picture for that, but I couldn't find one that, or put one together in time. So let's talk you through that. So the first component, as I previously mentioned, is that all the Arc-enabled services, including Azure Arc-enabled Kubernetes, deploy an agent. So in the case of Arc-enabled Kubernetes, the agent is actually a set of pods that get deployed on your Kubernetes cluster's control plane. Those pods include the trusted channel to the Azure Resource Manager. It does include, in the AKS hybrid deployment options case, it does include the telemetry pod. It does include a billing pod that allows us to basically funnel all that usage information up into your Azure subscription billing module. You will, if you look at your Kubernetes cluster once it's deployed, you'll find a namespace called Azure-Arc. That is basically where all those resources go into, and so they're isolated from everything else in the Kubernetes cluster. And that's basically those pods. Those pods are there to maintain an authenticated connection to Azure, synchronizing cluster metadata with the Azure Resource Manager so that they are reflected up into Azure and show up on their Kubernetes clusters. And it's also gathering metadata like cluster versions, node count, namespaces, Azure Arc Agent versions. So the Azure Arc Agent can update itself when there's a newer version out, so you don't have to think about updating that. It will automatically do that. If you don't want that, you'll have to actually flip a configuration bit. But then you might miss out on all the improvements that happen basically every other week on the Arc platform side. It also gives you monitoring for compliance states, source control, configuration resources applied to the cluster, and it's orchestrating interactions between Kubernetes and other Azure Arc components. So you want to deploy SQL managed instance, that agent actually manages the relationship between the agent that deploys the managed instance and also the Arc component. So what are the key benefits here, right? So the key benefits are that the general benefits from Arc that we talked about in previous units. The Arc-enabled Kubernetes also enables enhanced support for automated updates to cluster configuration by GitOps. What that means is that you can now have a Git repo with a Flux2 workflow configured that you just change your cluster configuration to say, I want to have 5 more nodes in my virtualized AKS hybrid deployment, and I want these namespaces configured, and I want this Helm chart deployed with the application in it. And now you just basically make a change to that Helm chart or that GitOps configuration in Azure DevOps. Once you have that, it gets pushed automatically down, and your Kubernetes cluster reconfigures as desired. The same thing works the other way around. Somebody goes in, uses kubectl to change something on your cluster. Now Flux v2 would go back and say, oh, that configuration doesn't match what I wanted it to be, and we'll basically reconfigure your cluster so it's the desired configuration. It also allows you to enforce runtime policies that affects the clusters and the pods. So for example, you can only say, these trusted users in Azure Active Directory can actually deploy applications. So a pod that's deployed by somebody outside of that group would never be started, for example. Or pods need to be scanned by some third-party tool like Palo Alto's Twistlock or something like that. So you can all have those policies, and say, or Azure Arc-enabled Defender for Containers needs to be running on a namespace so that it actually can deploy pods. If that's not there, then nothing will happen. The pod will get rejected. You'll see an alert in your dashboard, and you'll get that. Same with Azure Monitor Container Insights. That gives you the capability to manage and monitor, to have a rich monitoring experience for all your containers running anywhere. either in our Arc-enabled Kubernetes, but also in AKS on Azure Stack HCI. And we'll talk more about these features as we go through some of the other modules here. So with that being said, time for another knowledge check and see if you all paid attention.
I love that. By the way, there's a ton of more stuff than just these benefits, right? One thing we just had a question in the chat was about the Key Vault integration. So that's obviously one as well, which is highly beneficial. I also love, for example, the integration of like managed identity, right? So if you get this managed identity, as soon as you connect your cluster with Azure Arc, which then your applications can even use. And so there's a ton of other things as well, which is awesome. So let's go, as you said, go to the knowledge check. And so I hope you all listened carefully to what Mike had to say and looked at the screen as well, because it was there. So the first question here is, which namespace hosts the Azure Arc-enabled Kubernetes agent? Again, here you can use the link. It's the same link again, where you can go to that question, and we see already some answers coming in. To be fair, I think that's a pretty easy one, Mike, right?
Yeah, it's quite straightforward. So, but let's talk about the other namespaces here that are on that list, right? kubepublic is kind of something that you would create yourself to do install some Kubernetes extension, right? Like the dashboard or something like that. And then kubesystem is kind of where Kubernetes deploys all its stuff that it needs to run itself, the scheduler, the API server, the etcd database, all the credentials, all that stuff will end up in kubesystem. The default namespace is kind of an interesting one. Most customers I've seen so far have a policy in place that prevent deploying anything to the default namespace, because that one's usually not very secure. It doesn't have any RBAC rules on it by default, and it's the one kind of like a catch-all. If Kubernetes doesn't know where to put something, or you don't specify where to put something, it'll end up in default. Yeah. So if you don't find your resources, go look in default. It'll probably be there. Azure Arc is actually the obvious answer here, and that's where all the Arc agentry goes, where all the other Arc-enabled services go. Not only the Arc-enabled Kubernetes agents, actually all other agents will go into that same namespace as well. There's one small exception. If you enable Azure Arc RBAC on your Kubernetes cluster, it will install two things. One's going to go into Azure Arc, and the other one's going to go into kubesystem, because it needs permissions to read system credentials and also publish system credentials and namespace RBAC rules to Kube, which are basically all hosted in kubesystem. So, okay, so let's hop to the next question if we have one.
This is absolutely, by the way, the great benefit. If you actually have some of the people working on these technologies on the call, you learn a ton of different things, even with some extra knowledge here. So I didn't even know that. So awesome. Thank you, Mike. So the next question here is, which of the following is not an advantage of our Azure Arc-enabled Kubernetes? And we might also, again, need to talk a little bit about this, Mike, what the right answer is here. Maybe you have something to share on this, since you're working on this as well. So this is a little bit of a straight session. So if you're really upfront, you probably have seen some stuff and you're probably now confused about what the right answer is. So is it A, GitOps-based configuration and workload management? As far as I understood and listened to Mike, and we saw that, and we will also see a little bit more about GitOps a little bit later on, I would say that's definitely a benefit enabled by Azure Arc-enabled Kubernetes. B, use Azure policy for Kubernetes. Now, if you paid attention, we mentioned the word policy a couple of times also in the beginning, in the introduction. So this is definitely also something which is there. And then C, use of Azure monitoring container services. So also, Mike, I think just on the last page, I think you mentioned monitoring. So I believe that we can also say is a benefit. And so with D, managing cluster creation. Now, this seems to be something which we haven't really covered yet, but maybe you can also comment on that. And again, please, people, vote. I see there is probably the most controversial question here so far. So
that's the most. It looks like it's the most controversial one, right? So So definitely, as we said, GitOps-based configuration and workload management, that's there in the combination with Flux v2 and the Azure DevOps integration, Arc-DevOps integration. That's definitely there. Using Azure Policy for Kubernetes, yes, please. We have that. It allows you to basically control who can deploy pods, who can start pods, what the pods need to look like, etc. I think I missed that one because the name is kind of off. But yeah, it's definitely Azure Monitor for containers is definitely there. The managing cluster creation, that is true as of time of when we wrote those questions. As of now, we are actually in public preview with Arc provisioned clusters. So this module, we're talking about Azure Arc-enabled Kubernetes, but there is something that's called Azure Arc provisioned clusters, which actually allows you to, after installing a control plane component and agentry on your on-premise system, now you can actually deploy AKS clusters directly out of the cloud using the portal and using the Azure CLI or PowerShell modules or the REST APIs and ARM templates. And once we GA, it will have all the goodness around Terraform and all the fun things we can do with GitOps. And so now you will get the option or the opportunity, but it will only work for AKS hybrid clusters. It will not work for any third-party Kubernetes distro or any other cloud. So that will basically be a benefit of using AKS everywhere, basically in the cloud and on-prem. But more on that in a different session at a different time. Let's move forward.
Awesome. So let's move again to the next unit here in this module. And I want to keep this pretty short, but I want to go through a couple of things because this is now, so how do I actually connect a Kubernetes cluster to Azure Arc, right? There are a couple of steps I need to do this, and there are a couple of prerequisites which I need to be aware of. So first of all, again, we can look at some of the prerequisites here. As you mentioned, again, it's as we already discussed, it will then deploy an agent in the Azure Arc namespace of the cluster, and that is basically how it connects. That's basically the principle how we actually get a Kubernetes cluster connected to the Azure control plane using Azure Arc. So if you look at this, obviously, we need to have a Kubernetes cluster. Now, again, this is true when you connect a third-party solution. If you're using AKS hybrid, then you might deploy that. You already deployed, for example, the Arc resource bridge and so on. I'm not going too deep into this. Then that will probably allow you to deploy these as well. To actually then communicate, this is a question we get a lot. We obviously need some outbound connectivity. The agent needs to talk to the Azure APIs to actually, which are some target URLs. You can find that in the documentation. And make sure that the agent can actually connect. Now, this is very important. This is only outgoing traffic, right? There's no need for you to open any ports to the inbound traffic or anything like that. It's all outgoing connectivity and obviously encrypted as well. So that is another thing. And then obviously you need to have an Azure subscription or an Azure environment. You need to have an Azure tenant with one Azure subscription. I'm going to say that on purpose, where you can connect your Kubernetes cluster to. And you need to have certain rights to do that. That's important. If you're not the owner of the subscription or in general, you need to have some rights you need to assign. This is also, by the way, if you're doing that as a user, but you can also use, for example, a service principal to connect that. And that permission here, that role-based access control, is the Kubernetes cluster Azure Arc onboarding role, which we actually built into the Azure RBAC. So that's another thing. And then obviously, to actually connect that, you need to run some commands. In the case of third party, you would then run the Azure CLI or Azure PowerShell, for example, to actually connect that. Running the following commands. So this is what I want to talk about in terms of what we need to do here. And then you have here, you can go through the list by yourself, but basically you're going to run a command using the Azure CLI. which will then connect the cluster to the right solution. Again, you will obviously need to provide the subscription and so on, and log into the right tenant and so on. And again, you can basically connect these clusters running anywhere. We are now talking a lot about on-premises, but you can also onboard third-party cloud vendors as well if you want to. Now, I want to quickly, instead of talking about this too long, I want to quickly show you what happens after you onboarded a Kubernetes cluster. So if you then go to the Azure portal and you go to Azure Arc, that's the view you will get. And if you scroll down, you can see here under infrastructure, you can see here a couple of things which we can actually onboard. Now for us, as Mike went through, these are the things you can onboard, but where we're going to have a look at is Kubernetes clusters. And if we go to one of these, you can see here the list of different Kubernetes clusters using Arc. I already onboarded these to my environment. So if we have a look at one of these, this now looks like an Azure resource because it's Arc enabled, like all these things. This is like outside of Azure. However, it's connected with Azure Arc. So that gives you a couple of benefits immediately. First of all, it's integrated in the Azure Resource Manager, which then gives you things like role-based access control from Azure. You can also use tagging and things like that. And you get a couple of other things here as well, right? So you can see here the list. It almost looks familiar than AKS running in the cloud, but this one gives you same or similar management capabilities, I should say. Like for example, let's have a look at monitoring. As we mentioned before, one thing we can now leverage is Azure Monitor. So you can see here, I can configure my monitoring and I can see the utilization of my cluster or nodes or even containers, right? And see what's going on. I can also set up alerting, obviously. Again, can do many different kinds. We also want to make it easy for you. So we give you some recommended alerts, which you can enable and say, hey, we want to manage or make sure that we send alerts when that specific scenario happens. One thing I also want to quickly highlight here is a new announcement we just did, I think here at Microsoft Build, I almost want to say Ignite, is the managed service for Prometheus for Azure Arc-enabled Kubernetes, right? We have that. I think we announced GA for that on AKS in Azure, but now we can get a managed Prometheus solution also for our Arc-enabled Kubernetes clusters here on-prem as well. So again, there's a couple of more things we will do. We will probably dive in a little bit later, but let's go back to the Learn module and actually go even back to the knowledge check here.
Before you do that, Thomas, I have one thing I wanted to bring up is, so as Thomas was showing the general onboarding experience for clusters that are not AKS clusters, if you deploy AKS hybrid, though, the Arc enabling those is actually automatic. If you choose the command line parameter, enable Arc, then when you create the cluster, it will automatically be connected to Azure Arc and will show up in your portal. So you don't have to go through those steps for hybrid AKS or AKS hybrid in that case. And also you can enable any or disable that for a cluster after you have deployed it using a simple PowerShell command in or the Windows Admin Center experience for AKS hybrid.
Awesome.
That being said, off to knowledge check.
Perfect. So with the first question here for this part is, which Azure RBAC built-in role allows you to connect Kubernetes cluster to Azure? Is it A, Azure Arc Kubernetes Viewer? Is it B, Azure Connected Machine Onboarding? Is it C, Kubernetes Cluster, Azure Arc Onboarding? Or is it D, Azure Kubernetes Service Contributor role? Now, I believe this is like a tricky one in the sense that you need to just listen to what I said, because probably it could use all of these different things. I don't know if they all make sense. Some of them even exist, right? Some of them don't, but I think there are different kind of options. So again, please feel free to vote on this as well. And I see there are some answers coming in. And again, it's a very tricky one, I have to be honest. What do you think, Mike?
Yeah, I'm not sure. Viewer kind of means that I'm not a person who can write to something, so I don't think A is the right answer. Looking at the other ones, D, Azure Kubernetes Service Contributor role. I don't know. It has nothing to do with Arc, so I'm not kind of sure. The Azure Connected Machine onboarding kind of sounds right. So maybe that, or Kubernetes cluster, Azure Arc onboarding. Seems like a Microsoft name that Microsoft would choose for something like that. So B or C would be my guess, my wild guess. But we'll see what the people say. There you go.
It is actually C. So for those who are selected, especially the ones that selected B, Azure Connected Machine onboarding, we have something very similar for the Arc-enabled servers. And so there is like, it could be that you potentially just read until B and thought, yeah, B is the one. But for the actual Kubernetes, we call the role is called Kubernetes Cluster Azure Arc Onboarding. So let's jump to the next one here. So which of the following is not required to connect a Kubernetes cluster to Azure Arc? So this is very important. I think I tried to basically mention that during my part to make this a little bit more clear. So be very careful. Every letter counts here. Make sure you look for this. So is it A, multiple Azure subscriptions, B, an existing Kubernetes cluster, C, outbound connectivity from the Kubernetes cluster, D, the Azure command line or CLI or Azure PowerShell? So one of those things are actually not used. And again, I believe this is like a trick question, to be honest. This is really a trick question. Or do you agree, Mike?
I think it's a tricky question, yes, because I think the answers are not really complete, right? If I look at CLI and PowerShell, yeah, that's kind of the thing you would need to do it. But you could also, if you have Arc connected servers on that VM or that physical machine running Kubernetes, you could actually also do it from the portal. Outbound connectivity from the Kubernetes cluster, yeah, that's kind of a must, I think, because otherwise we can't download container images. And since we're onboarding a Kubernetes cluster, I think B, an existing Kubernetes cluster, makes total sense. So I'm not sure about the multiple Azure subscriptions, but I did somewhat pay attention to your first few sentences where you said single Azure subscriptions. So I think that is the right answer. And having multiple Azure subscriptions is fun. You can have multiple Azure subscriptions, but the Kubernetes cluster can only reside in a single subscription today. Right?
Absolutely.
And I don't think there's a way to move clusters from one subscription to another. You have to offboard it and then onboard it to the new subscription, which doesn't impact anything on the cluster. It's just a representation in Azure that changes when you move it between subscriptions. But I think you have to offboard and onboard to actually facilitate that change.
Could be the case. So yeah, it's like you need obviously one Azure subscription, not multiples to do that. But again, if you're running an enterprise, you probably have already many other subscriptions. You have Azure landing zones maybe deployed, so you will depend a little bit on your workload. So, but again, for Azure Arc-enabled Kubernetes, you can do that. Now, interestingly, I did not know that about the moving. You need to onboard, offboard, and onboard again. I know that for the Arc-enabled server one, you don't need to offboard. You can basically just use Azure Resource Mover to actually move it to a different subscription. But I don't know how that is.
I'm not 100% sure with Kubernetes clusters either. So I'm just hypothesizing here. So
perfect. Good. So let's go back and let's go into the Learn module talk a little bit about the next module, which is all about Azure policy. So go ahead, Mike.
Okay, so Azure policy. So as we talked a little bit about this before, Azure Arc centralizes and streamlines management by enabling a range of different services on your on-premise or non-Azure Kubernetes clusters, right? Such as Azure policy. So if you know AKS in the cloud, it does have native Azure policy integration, and it's all fun and games. You don't need Azure Arc for that. But if you have a Kubernetes cluster that's either running on-prem, as AKS hybrid or as something else, or running somewhere else on a different cloud provider, you will need something that helps you apply policy to those. So the way that works is that Azure Policy for Kubernetes leverages the Open Policy Agent. And guess what? It deploys that as part of the Arc agent agentry onto your Kubernetes cluster, wherever it's running. And so where it deploys that? Into the Azure Arc namespace. And so the OPA agent will show up as another pod in that control plane in the Azure Arc namespace. And that agent will check periodically. It needs outbound connection to Azure, obviously. It checks periodically for Azure policy assignments targeting the Kubernetes cluster, and then use its admission controller pods that sit also partially into the kube system namespace and deploy policy definitions there, using custom resources to apply constraints and enforce that get enforced by those admission controller pods. So if you put the constraint on that, for example, my pods need to have a base image of Alpine Linux version X, and somebody tries to deploy a pod that's based off of an Alpine Linux version Y, then that pod will get rejected and the user will get a respective error message. We do have some default policies and policy definitions that come with Azure Arc-enabled Kubernetes, and some of those default policies are, for example, not allowing privileged containers. That prevents the creation of a privileged container. So you might ask, what's a privileged container? A privileged container is a container that runs with credentials that have access to the container host. And in a production environment, you probably don't want that unless you really, really need it. But usually that will be one that gets applied by default. All Kubernetes clusters should only be accessible over HTTPS. So if somebody provides an ingress connection but sets up only port 80, that service will get rejected. You should only use allowed external IPs is another one. You really don't want to have like a star policy that allows any external IP to address your pods internally. So you want to make sure it's locked down to a certain sitter range or a certain pool of IP addresses, or even down to one external IP. If you have like a firewall with an intrusion detection system that basically just exposes a single IP. You can define your allowed ports, so like 80.443 or just 443. You can have SSH access to a service, whatever you want to do, but you can define what are the allowed ports. Allowed container images, I already talked about that. So you can actually control which container registries things come from. Make sure you if you apply the policy, make sure you also allow the mcr.microsoft.com, and also what is the new one? K8cr.k8.io, which is the one that's replacing gcr.k8.io. So make sure you allow those, because that's where all the default pod images come from for the Arc Agent 3 update, for all the Kubernetes bits and pieces. They come from there. So make sure you allow those through, because otherwise your cluster will go stale and run out of support relatively quickly with the speed that the community is acting and building stuff. One other one, Kubernetes cluster pods should only use approved host networks and port ranges. That kind of like helps you separate pods for different organizations inside your Kubernetes cluster. So you can say accounting has this network configuration, sales has this network configuration, so they can't cross-pollinate and do things across. So the way to implement Azure policy for Kubernetes on Azure Arc-enabled Kubernetes clusters is, well, you need to have an Azure Arc-enabled Kubernetes cluster first, right? So, and you need to know the Azure Resource ID. You can find the Azure Resource ID in the portal. You can just simply click on the copy button, then you have it. You have to have access to the cluster with an account that has the cluster admin role. The cluster admin role is a role that's basically in Kubernetes RBAC defined, and it usually is connected to an Azure AAD account or group account. You have to have Helm 3 installed because it's the Azure policy is deployed as a Helm chart. And we talked a little bit about Helm charts in the beginning, which is kind of the package manager for Kubernetes manifests. You need Azure CLI, hopefully the latest version, and you have that already because you needed it for deploying Azure Arc. And you need outbound connectivity to Azure so we can pull the pods. We talked about that a little bit. Details on the URLs are in the Azure policy for Kubernetes documentation. And one thing that we've heard from customers over and over is like, there's about 90 different places we have to look for URLs and ports to allow. So there's an effort going on across all the Arc services right now to actually improve that experience. And very similar to what Microsoft 365 is doing, you just basically say, I have my stuff deployed in East US or in Western Europe or wherever my region is, and it gives you a JSON file with all the policy rules you need to put into your firewall to actually allow the necessary things to access all the services. So that's going to make the configuration slightly easier, but that's, I think, is another 4, 5, maybe 6 months out. But it's an effort consolidating that. So that's we've heard the feedback, we're working on it. So then you start an Azure CLI session, you sign into your tenant, you register the Azure Policy Resource Provider if you haven't used that before. So the subscription needs to be enabled for that. Then you grant the Policy Insights Data Writer RBAC role to the Arc-enabled Kubernetes cluster. So that basically allows the policy engine in Azure to set policies on your Kubernetes clusters. You install the policy add-on using its Helm chart, and then you can go away and go in and have your security team define the policies. All right, so that was a lot about policy and a lot of detail. And I will give it over to Thomas to go into the knowledge check.
Perfect. In terms of time, we're going to speed it up a little bit this time, but again, you're still obviously feel free to vote for this case. So the first question is, which Kubernetes component is used to implement the Azure policy for Kubernetes agent? Is it A, a service, B, admission controller, C, ingress controller, or D, namespace? Now, I paid very much attention to what you said, Mike. So for me, I think it's very clear, but let's see if people can vote on that. Otherwise, again, in terms of time, we will go this time a little bit faster. And again, just for you to know, you can do this Learn module all by yourself and go through everything we just talked about and even more as well. So for me, this is B, the admission controller. Again, I paid very much attention to Mike, what he said. So let's move to the next question here. Which of the following is not a capability of Azure policy for Kubernetes? Is it A, reporting, auditing, and compliance data, B, checking periodically for Azure policy assignments, C, deploying policy definitions into a cluster as a custom resource, or is it D, allowing secure connections to Azure Arc-enabled Kubernetes cluster from anywhere? Now, I haven't really spoken about this, and this is a little bit my fault. We have a feature which allows you to actually do secure connections to your Kubernetes cluster, but in my opinion, that is not really policy. So what do you think, Mike?
Yeah, I think that's definitely, there's a portion of that, obviously, that's a policy, right? Because that's how you enforce it. You could enforce it, but there is actually another portion that allows you to configure that outside of policy without having to use the policy agent at all. So if you want to use something different to apply policies, you can use that, and then also but still use Azure to control your secure connections.
Perfect. Yeah, so it's the is not a capability of the Azure policy stuff. So we have one more thing. I just want to talk highly on this. I'm not going to do deep in this. You can go that through yourself again because of time. There's obviously one thing you can do really cool is using GitOps and Flux V2 to manage your Kubernetes cluster, also the applications running it. And if you want to learn more, I have some great demos online on this, how you can implement that. Super easy. You can do that with your AKS cluster in Azure, but also with any Arc-enabled Kubernetes cluster out there as well. So it makes it super easy to actually deploy applications in kind of like a DevOps mode. And so we're also going to switch here really quickly, not going through that knowledge check just because of time. And I think let's summarize here a little bit on what we just learned. Again, the learning objectives, what you just saw, is like, okay, so a little bit on Kubernetes, and again, Mike did a great job explaining the concepts of Kubernetes, Azure Arc, and Azure Arc-enabled Kubernetes. You saw quickly how you can connect a Kubernetes cluster and how you can, for example, look at the monitoring pieces and so on. We also had a look at the policy stuff, and which you don't have time to is go through the GitOps stuff, but again, you can do that on your own time. So if you want to learn more, check out the following resources with that great link here. Again, you can also use the QR code to get to that. Make sure you go through the Learn module. Highly recommend doing that to figure out, hey, how can I go through? And you can do that on your own pace. There's a lot more information, by the way, which we hadn't time to cover, or which just is too much, right, for this session. So you can go through in all your own time and figure that out. Again, here is the link to the Learn module, and you can use the QR code as well. So Mike, do you want to add also some words to this as well?
Thanks, Thomas. So I think, yes, please do enjoy Build. Provide feedback about the session. I know we ran out of time. It just means that I talk way too much. But yeah, I hope you can enjoy Build. You have learned something new here. You've seen something new. Thanks, Thomas, for the demos. And we will definitely stick around for some questions. If you have more, type them into Q&A. We'll get the summary there, and we'll try to come back and answer some of those questions in other sessions, or get back to you with an answer as we can. Thank you so much for paying attention and going through everything here with us, and I hope this was useful for everyone.
Thank you very much. Thank you. Have a good day.